Mr. Jonathan Crabtree. I think you're all eagerly waiting for his lecture. So let me read out from the official handout here. Elementary maths historian Jonathan J. Crabtree is a guest lecturer at Indian universities and schools. Having reviewed writings in Latin, Greek, Arabic, and Sanskrit, his provocative presentations reveal how India's lost ancient mathematics is easier to teach and understand than the Western maths taught today. His ideas, papers, and presentations can be downloaded free from www.jonathancrabtree.com. Thank you very much. Looking forward to your lecture.
Okay, thank you very much. First of all, namaste. I'm going to go through this presentation so quickly. The goal is for me to present more information than you can possibly absorb. But that doesn't matter because the PowerPoint slideshow you'll be able to download at the end of this lecture. And the slideshow probably has maybe an extra 100 slides to it of content that I'm just not going to have time to do in this hour. So I may as well just get stuck into it. This is a two-part lecture. So the first part is dealing with the topic of my paper, which is negative and positive quantities on a Brahma Guptan plane for India's primary classes. And the second part, which I probably won't get that far into, is why India must change its story. Because you see, we've got a bad maths history has led to a sad maths mystery. Much of what we think we know about the history of India's mathematics and how it came to us today, much of what we think we know is wrong, and that's been an area of my research for quite a long time. So, this is a quote. There are no studies demonstrating how negative numbers and algebra can be taught to such students in a meaningful way. And that's the publication, Mathematics Education in India, Status and Outlook. And one of the gentlemen who edited that is possibly on the campus today. Negative numbers, usually introduced early in class 6, are known to be a problem area. That's another quote from that same report. Negative times negative is positive is problematic to justify, and that's from yourself this morning. So I've put that into the slideshow. Now, what I'm going to reveal is now Brahma Gupta's simple idea of zero lets India's children understand that negative times negative is positive with absolute rock-solid certainty and intuitive conviction. So I've had children aged 12 explain exactly why that can only be positive, and they would think that adults were crazy if they thought it was any other way. Here's some more quotes from Professor Dinesh Singh's inaugural address yesterday. Something is amiss. Why are we adrift? What should be done? We need to gain insight from history. We must offer something tangible to policyholders. Sanskrit is in our DNA, but we never bring it into the learning of mathematics. Beautiful quotes just yesterday. So my goal is to answer questions like these and to give India's leaders and teachers the solutions children need. And to solve India's primary level mathematics education problems, I'm creating a free Sanskrit-based alternative to arithmetic called Podometic. So we heard this morning about competition in software. Well, now we're going to have competition in arithmetic, and people will be able to make a choice about what logical foundations they wish to pursue. The Western foundations based on ancient Greek mathematics, which did not have 0 or 1 as numbers, didn't have negative numbers, or the very powerful suite of laws that Brahma Gupta gave the world in the 7th century. Now here's a quote from Edmund Landau, famous mathematician. Please forget everything you have learned in school because you have not learned it. So I thought that if he's bold enough to say a quote like that, I can invent something. please forget much about what you learned in school about arithmetic because you don't understand my definition of zero. And that's what I imagine Brahma Gupta might say if he were alive today. So in the West, there are many people who cite Brahma Gupta, maybe more in the West than possibly in India. So here we see broken ideas of Brahma Gupta's writings. Brahma Gupta defined zero as the result of subtraction of a number from itself. He also gave the following rules for operations on what he called fortunes and debts. So what they've done is they've converted Brahma Gupta, an astronomer, into Brahma Gupta, an accountant. And they have made a whole lot of nonsense out of the Sanskrit shlokas. So typically what we see in the West, when people do quote Brahma Gupta, is something like the product of 2 debts is 1 fortune. Now, I'd love that secret because then people could multiply their mortgage by the credit card debt and become rich. But that's absolute nonsense. You cannot multiply debt by debt for the simple reason you cannot multiply 2 nouns together. One of those numbers has to be a number and an adverb. So here's another book. This one's, so this one here, that's an Australian textbook. This one here, I think, is from North America. Brahma Gupta, and it's even got the years of his birth, was a Hindu mathematician and astronomer who lived in the 1st century. So much for quality control. And again, there's the idea of debts and assets, and the product of 2 debts is 1 fortune. But if you look into the history of Indian mathematicians, they never ever mention a financial metaphor for the laws of positive and negative quantities and zero. So here's just a very quick summary of some of the major Indian mathematicians, and you'll see that, and this is just on that topic of negative into negative is positive, they're not talking about debts, they're not talking about assets. They're talking a mathematical language that I have unpacked and expanded and interpreted. So if we turn to ancient China, Li Hu, in around about the 3rd century, wrote, "I read the 9 chapters as a boy and studied it in full detail when I was older. I observed the division between the dual natures of yin and yang, the negative and positive aspects, which sum up the fundamentals of mathematics." So even before we obtained the knowledge of the ancient Indian writers, the foundational philosophy of yin and yang is consistent with the laws of physics, as I'm going to demonstrate. So we had initially, 2,200 years ago, we had better explanations of elementary arithmetic than are taught around the world today. So, if maths is language, it must obey the parts of speech of language. So I'm just going to mention a few words on the grammar of arithmetic. And if I ask adults -7 minus -4, the usual answer is -11. And the reason why is that there's no nouns. The semantic structure of that question is adjective, adjective, verb, adjective, adjective. I might as well ask something about the blue sky chasing the purple moo. I mean, it's just absolutely nonsense. There are no nouns in that. Now, the adults will struggle. They'll come up with -11 because they'll struggle for the rules they memorized at school. And is it 2 negatives make a plus? So they've got no intuitive understanding of the mathematics. And they try and work it out from recalling those rules, and they get the wrong answer as a result. Now, if I ask children 7 negatives minus 4 negatives, every child answers 3 negatives. It's about the most impactful change you can do in your teaching that I can offer you. Why? Because the semantic structure is correct. We've got to get the parts of speech right for our language of mathematics, because mathematics is a language. So the structure, as you can see, becomes adjective, nouns, verb, adjective, nouns. And that just becomes simple. Nouns make maths meaningful. So we've all learnt about the concrete and the abstract and the symbolic and the pictorial representations of mathematics, but we don't actually put that into the words we use in front of children. Okay, so what I've got here is a template of the parts of speech involved with addition. So we've got units that we're counting. So this is objects. So we've got the augend, which is the first number, is an adjective describing the count or measure of the units. Add, which is a verb. Adjective, a count of more units, equals a count of units. And that's, by the way, the address that you can download this slideshow even right now. In multiplication, it becomes a little bit more interesting, because we've got the structure of adjective for the multiplicand, we've got nouns for the units, we've got a verb, an action of multiplying, and the multiplier is actually an adverb, which says how many times the multiplicand is going to be either added to 0 or subtracted from 0. And that then gives us an adjective noun, which is the product. So we'll turn to the product of two negatives is positive, and I just created this presentation last night based on what I was learning yesterday. So this is a typical demonstration of how we teach students why negative into negative is positive. And that's from an article that I wrote. So I understand the complexity, and I made a couple of mistakes when I was writing out that concept to prove negative into negative is positive. But as we'll see in a few minutes, this is not necessarily the best way of going about it. So let's turn to Brahma Gupta. And Brahma Gupta defined 0 as the sum of a positive number and negative number of equal magnitude. And that's from the Brahma Siddhanta, chapter 18, and that's actually from line 38. So the verses to look for in chapter 18 are verses 30 to 35. So 0 was defined by Brahma Gupta as the sum of a positive number and a negative number of either equal count or measure. And Brahma Gupta originally wrote about the laws of dealing with quantities. So if you look at the actual Sanskrit, he's talking about the laws of positive and negative quantities and 0. But the quantities are isomorphic to numbers. So that's why we always talk about Brahma Gupta giving laws of number. So what I've done is I've taken the Sanskrit of Brahma Gupta's laws of mathematics line by line, and this includes the commentary of the critical edition from Benares in 1902, and I've then had the help of various professors and Sanskritists to not just translate it, but I've been looking for the interpretation. How would Brahma Gupta have explained his own laws of mathematics to his children? Remember, I'm an elementary mathematics historian. You know all way more complex mathematics than me. My area of focus is on primary classroom mathematics. So I've pulled apart out of the Sanskrit 18 laws of Brahma Gupta, and I'm just putting up here quickly. So you can see that nearly all of them are what we would expect, except there are a couple of surprises. And remember, you can download these slides. You don't have to worry about taking photos. You can download all of the presentation, even right now. So let's see a simple proof for Brahma Gupta's multiplication law number 2. The product of two dashed numbers is positive. Now that's an interesting choice of words. I say dashed numbers because we say negative into negative, or we say minus into minus. Both of those statements have incorrect grammar. So let me explain. So via Brahma Gupta, we multiplied positives and negatives by either adding to 0 multiple times or subtracting from 0 multiple times. So this is read negative A into add B. So it's negative A added to 0 B times. So no one's really aware of how multiplication actually has to be understood. And negative A into subtract B means we are taking negative A and we are subtracting it from 0 B times. So this is kind of like a new algorithm for multiplication, because what's been taught for centuries around the world since February 1570 is that AB, or A into B, is defined as A added to itself B times. And A to the power of B is defined as being A into itself B times. both those algorithmic definitions have been wrong for hundreds of years because they've been missing the numbers the Greeks didn't have, which is 0 and 1. So don't go to the mathematics dictionaries to understand mathematics. That's the lesson I learnt. So with integral multiplication, A is the adjective describing counts or measures of noun quantities, and B is the adverb describing verb counts of additions or subtractions. And I'm just talking about integer arithmetic here. So, negative A into subtract B times equals negative A subtracted from 0 B times. So negative 1 into subtract once is simply negative 1 subtracted from 0 one time. So here we've got 0, which is defined by Brahma Gupta as the sum of equal numbers of opposite counts. So 1 positive and 1 negative is 0. And we can just use pictures for children. So we've got a green 0 here, and then what we do is we run the new Sanskrit inspired algorithm. We simply subtract negative 1 from 0, and you see with your eyes that the answer is positive 1. So this is the sort of explanation we should be explaining to children. We should be giving them the correct definition of 0 from the Sanskrit, and then we should be saying using the correct grammar to explain negative 1 subtracted once gives you the 1 positive. And if we compare the two between the Sanskrit-based demonstration or the Western demonstration, children will understand the visual approach easily and instantly once they get the definition of what 0 is all about. And you start to see this coming into school books around the world via the pedagogy called integer tiles. Now, with our corrected understanding of integer arithmetic, we can now depict it on a Brahma Guptan plane, and there's a link where you can download the few pages I've written about the Brahma Guptan plane. So what is it? It's like the Cartesian plane, but what we're doing is we're talking about positive quantities and negative quantities, either added to 0 or subtracted from 0. So they're the four combinations we've got. So we've got 4 quadrants. So in the first quadrant, we've got positives being added to 0, and 0 plus positive plus positive plus positive. In quadrant 2, we've got negatives being added to 0. So as you might be able to figure out, in quadrant 3, we've got negatives subtracted, because this way is subtraction, above the line is addition, this way is negative, this way is positive. So we then have negatives subtracted from 0 becomes positive. And on this side here, we've got positives subtracted from 0, which become negative. So we can start to do area models using negative quantities. So we typically only use the area model for modelling positive counting numbers in the early years. But now what we can do is we can start to find a place on the Brahma Guptan plane to show the areas of positive quantities and negative quantities. And then what we can do is we can solve problems that stumped people like Cardano and Diophantus, because all we do is we can then add up the reds and then cancel them against the blacks, and then that'll give us the total answer for a problem like 2 minus 10 all into 3 minus 10, which has never been able to be demonstrated geometrically before. Why? Because it's actually genuinely a negative number into a negative number. All of the instantiations of negative into negative that rely on the distributive property of multiplication, they're simply illusions, because what they're really depicting is it's not negative into negative, it's a subtraction being subtracted. And if you look at my paper, you'll understand what I mean about that. So here's a summary of the Brahma Guptan plane with the positive and negative areas. So fairly simply, positives being added to 0 create, in effect, a times table up here. And we've never had the times tables ever shown to children for the integers. Now we can. So negatives being added to 0 are negative, negative subtracted from 0 being positive, and positive subtracted from 0 being negative. When you start off with things like integer tiles and the simple definition of 0, all of these ideas become accessible to children probably in class 2 or 3. So what happened in ancient China, what happened in ancient India, they started with the integers, and they started with a symmetrical system of understanding the world around us. So, again, that's just the address for the paper to download later on, and that allows me to speed through the presentation a little more. So I'm jumping on to part 2 of this talk, which is why India must change its story. Bad maths history implies sad maths mystery. And the sad maths mystery was my experience of school mathematics. And I was a slow learner. I thought I was stupid, but what I was realizing is that I was a very deep thinker, and I was trying to make sense of the mathematics, truly make sense of it, and I couldn't, and so I thought I was stupid. So to some extent, the key to success in mathematics is not to think too deeply about it, but just to learn by rote the laws and the rules and the formulas, get the answer right, move on to the next chapter or the next book. But that's not my experience. I wanted to try and figure it all out. So I couldn't make much sense of what I was being taught, so I felt stupid. So don't worry about it, Jonathan. Mathematics is only confusing if you think about it. So we were actively encouraged not to think about what we were being taught. And that's a direct quote from me. So anyway, in 1983, I made a decision to change primary and middle school mathematics explanations. And you can see here in 1988, I'm starting to get quite a lot of publicity in Australia. One of the reasons being that when I teach mathematics to a maths class, they all have their eyes closed. They learn mathematics through creative visualization, which captures their attention and also locks the algorithmic approach that I'm teaching into their long-term memory one time. So in this year, 1988, I'm quoted for the first time, "I hope to change the way the Western world teaches maths," Jonathan said. So that's a long time ago. So it's about time I started to share what I've been discovering. Now, at age 7 in class 2, I pulled on a loose thread. The multiplication explanation my teacher, Miss Collins, had given me had been wrong for 398 years, and it's still taught around the world in classrooms today. And I argued with my teacher, and she was very confused. Not me. I was actually correct, even though I didn't know any of my times tables. So that classroom confusion in 1968 in class 2 led to a peer-reviewed paper. There it is there, you can download it, that reveals that Euclid's definition of multiplication, that has largely formed the basis of Western pedagogies for hundreds of years, is not Euclid's definition of multiplication at all. It's actually that of a man called Henry, who was a shopkeeper, who, when he translated Euclid's elements from ancient Greek into English for the very first time, he thought he'd whack in his own definition of multiplication instead of translating Euclid's. So all of the ideas that we use in classrooms for equal groups and arrays and so on for multiplication are wrong. They are not Euclidean concepts of multiplication. When I analysed Euclid's elements, I looked at every single proposition in Euclid's elements that related to multiplication, and guess how many times Euclid mentions the word addition, added, in the context of multiplication? In the entire book, it's a number Euclid didn't have because that number is 0. Euclid never said anything about multiplication being repeated addition, and yet I see book after book quoting Euclid saying that. And in fact, it was a man called Henry, who was a shopkeeper, who pulled off one of the greatest Swifties on the world, and we've been all teaching the maths of a shopkeeper who was not a very good person at arithmetic. So the more I pulled on loose threads, the more mathematics education unravelled. And bear in mind, this started 51 years ago. So I've had more than half a century to be confused about mathematics and try and make sense of it at a deeper level. So India, we have a problem. Many dislike or fear your maths. So what happened? Well, here's a saying from one of your famous heroes in India, Rabindranath Tagore: you can't cross the sea merely by standing and staring at the water. So I had to travel to find out if there's demand for India's original and true foundations of mathematics. And so I've been visiting classrooms in India. And in this classroom here, I had 550 children and probably about 20 adults. And they were all learning how mathematics works for the first time. This one was just from a couple of weeks ago in Kolkata. And the media, as you can expect, from a guy from Melbourne, Australia, travelling to India to teach the foundations of Indian mathematics to India's mathematics professors, has created a bit of media interest. There's usually a bit of scepticism at the start, but they do then eventually see that I'm taking a very serious scholarly approach. And I do like this article here because it's in English. I have no idea what all the other ones say. So, but they're good because they put Ramanujan or, Albert Einstein in the pictures, which is way over the top. So again, I'm just talking about arithmetic, basic operations on the integers. So obviously India's ancient integer logic got to us today, but how? What facts do we know? So what I'm going to do is summarise the generally accepted history of the transmission of Indian mathematics to the West today into this room. So Al-Khwarizmi wrote a book on Hindu integer arithmetic, which featured Brahma Gupta's ancient laws of sign for negatives and positives. And based on what he learned from the Indians, Al-Khwarizmi then wrote a book on algebra. Now, here it is, the book on algebra. And what you can see is from this book title, I'm not going to pronounce the Arabic, we actually get the word algebra from one of the words in the title of Al-Khwarizmi's book on algebra. So, continuing on, Arabic writers understood negative terms. We often read that one of the ways the Arabic algebra worked is that they removed the negative terms in the equations. So I've just got some quotes up here. I'm not going to read them. They're in the slideshow you can download. But again, after again, we have people talking about how the Arab algebraists would remove the negative terms to balance equations, right through to Keith Devlin more recently in 2012. Algebra means restoration or completion, that is removing negative terms by transposing them to the other side of the equation to make them positive. Okay, so from the Arabic world, India's mathematical foundations made their way to North Africa, where Leonardo Pisano, also known as Fibonacci, mastered them. And then Leonardo Pisano then documented India's mathematical foundations involving Brahma Gupta's definition of zero as a number, and thus Europe came to understand Indian arithmetic. So, it started off in India in the 7th century, travelled into the Arabic world in the 9th century, and was introduced into Europe the second time through Fibonacci in the 13th century. Because I say the second time because the first time it came, zero basically did not even come over for the trip. So what facts do we teach? Zero is defined as any number subtracted from itself, n minus n. Negative numbers are less than zero. Negative 7 is less than negative 4. And every basic arithmetical operation on the integers is understood and has been for centuries. Euclid in his book Elements defined multiplication as repeated addition. AB is thus defined as A added to itself B times, and A to the power of B is thus defined as A into itself B times. So, what we know about arithmetic isn't true. Every previous fact is false. Bad maths history implies sad maths mystery. So Indian students rank second last in the global test, as Professor Dinesh reminded us yesterday. Thank goodness for Kyrgyzstan. Now, everyone is entitled to their own opinion, yet not to their own facts. So I am a fact-based detective looking for who murdered India's mathematics. And I've understood what episodes in history the evolution of mathematics became corrupted. So, extraordinary claims. India's definition of zero never made it to either the ancient Arabic world or Europe. In the Arabic world, India's zero only came to exist as a placeholder, not as the power tool to solve simple problems like positive 3 minus positive 4, or negative 2 minus negative 4, or negative 4 minus positive 2. So we look at the evidence. Here's Brahma Gupta, famous astronomer and mathematician. So he was a scientist. He was basing his understanding of mathematics on observation of how the universe worked. What do we say? The universe is written in the language, and that language is mathematics. So he's about as close to understanding the laws of the universe as anyone and understanding that language. And yet we're following the philosophy of Aristotle and Plato. Do you want to follow the mathematical advice of the philosophers 1,000 years before India's mathematical innovations? Or do you want to follow your own Sanskrit-based mathematics, which directly links up to all the laws of physics? So, from his Brahmasphutta Siddhanta, year 628, I've analysed all the Sanskrit with the help of a lot of people, I must say. And we've got I'll look at the Sankalana laws of Brahma Gupta for addition, and here they are. There's nothing there that will be a surprise to anyone in this room, but the next slide will surprise you because I'm going to get rid of most of them, because it's only addition law number 1 that was understood in the Arabic world. Everything else was not understood in the Arabic world or in medieval or Renaissance Europe. The reason why is all the other laws involve negative or zero. And those concepts did not make its way out of India into the Arabic world. So let's have a look at Al-Khwarizmi. I had seen that the Indians had set up 9 symbols in their universal system of numbering. 9? And so they made 9 symbols, which are these: 9, 8, 7, 6, 5, 4, 3, 2, 1, and every number is put together above 1. So Al-Khwarizmi did not mention zero. And this is in his book on Hindu mathematics. Okay? He was the gatekeeper of what went through the Arabic world. He was the head of the House of Wisdom in Baghdad. 1 is the root of all number and is outside number. So Al-Khwarizmi didn't mention zero, and he didn't even accept 1 as a number. The next most important Arabic mathematician is Al-Uqladisi. Now, he considered zero a placeholder, but not a number. Why are the Hindi letters 9? So much for the 9 letters. 0, the aim is only to occupy the place. We multiply the letter by 0 to occupy the place, to tell us that there's a place and that it's empty. Now, I've only just read out the red bits. You can read in detail the shaded out areas. So 200 years after Brahma Gupta, Al-Khwarizmi did not accept 1 as a number. 0 as a number, never. 300 years after Brahma Gupta, Al-Uqladisi accepted India's 0 as a placeholder, yet not as a number. Why? Al-Uqladisi means the Euclidist. So he was known for his skill in studying the Greek geometry of Euclid and translating it into Arabic. So when he was translating, in effect, the goba board or the dust board techniques of the ancient Indians into the paper-based way that we use today, he just completely had no idea about India's innovation. His head was stuck in Euclidean ideas where 1 was not a number, there was no concept of 0, no negative numbers in Euclidean geometry, and so these people effectively blocked the transmission of Brahma Gupta's laws of mathematics through the Arabic world. So, India defined zero as the sum of opposing negative and positive numbers or quantities with the same multitude or magnitude. If the Arabic and European writers in medieval times really understood India's zero, where are all the negative numbers in their writings? So here's a quote. I have read a few dozen medieval Arabic books on arithmetic and algebra, and there is no hint of negative numbers in any of them. 0, too, was not regarded to be a number, but was merely the placeholder for an empty place in the representation of a number in Arabic notation, which at that time was India's notation. All numbers in Arabic arithmetic were positive. No Arabic author, to my knowledge, ever even contemplated the existence of negative numbers. And yet remember, Brahma Gupta defined zero as the sum of negative numbers and positive numbers brought together, cancelling each other out. Very similar with, for every action there's an equal and opposite reaction. So the maths myths we know. India's definition of zero as a number that was a sum of equal yet opposite negative and positive quantities was not embraced by the Arabic world. Al-Khwarizmi wrote a book on Hindu integer arithmetic which did not feature Brahma Gupta's ancient laws of sign for negatives and positives. Based on what he learned and documented in his book, Al-Khwarizmi on the Hindu art of reckoning, he wrote a book on algebra. No, that's not correct. Al-Khwarizmi wrote his book on algebra before he understood Indian mathematics. We assume that just because children learn arithmetic before they learn algebra, we assume that Al-Khwarizmi wrote his arithmetic before he wrote his algebra. No, it's actually the other way around. And how do we know? We know that because in his book on arithmetic, he refers to his previous book on algebra. So Al-Khwarizmi did not remove negative terms from his equations, despite all those previous comments. Al-Khwarizmi simply eliminated any positive term that was being subtracted in an equation. People from the age of Diophantus on have conflated subtraction with negative. Fundamental mistake. For example, ax squared equals bx minus c would become ax squared plus c equals bx. There are no negative terms in that. They're just positive terms because no Arabic writer used negative terms. So here we've got a comment on comparing Al-Khwarizmi's approach to Brahma Gupta's. Once again, Al-Khwarizmi's approach differs from Brahma Gupta, this time in not employing any abbreviation. So Al-Khwarizmi's writings were all rhetorical. They were all just paragraphs of texts. Al-Khwarizmi avoided using negative numbers or simply a larger number subtracted from a smaller one or from zero, whereas Brahma Gupta, like other Indian mathematicians before him, does not hesitate to make use of such negative numbers. It is difficult to imagine that Al-Khwarizmi, if he had read this chapter, i.e. chapter 18 of Brahma Gupta's Brahmasvita Siddhanta, would not have been able to profit by it, even if only to shorten the presentation of his work. The style of the mathematical reasoning that is at work in Al-Khwarizmi's algebra has nothing to do with what we encounter in the work of his Indian predecessors. So, in the year 628, Brahma Gupta had everything we need to explain and understand integer arithmetic. 200 years later, Al-Khwarizmi did not have one as a number, and a bit over 300 years later, Al-Khwarizmi only had zero as a placeholder. No negative numbers, no understanding or insight on how to use zero to solve mathematical problems. So now we introduce Leonardo Pisano. I'm Leonardo Pisano. I am the man most responsible for introducing India's arithmetic into Europe in the 13th century via my book Liber Abaci. As I got my Indian info via Arabic traders, I did not get to learn about India's definition of zero as a number or the rules of positives and negatives. Now, he spoke very highly about Indian mathematics, It's just that it seems he got it from people who did not get the original idea of Indian mathematics. So if he was going to say that, he might say whoops. So here I've got an overview of the history of the movement of zero. But this is the transmission of zero, not as a number, not as a foundational concept, summing equal and opposite forces or quantities, which is a remarkably intellectual idea. This is just zero as a placeholder. It starts off in northwest India near Binmal in the year 628, then goes over to the House of Wisdom in Baghdad, where it's picked up by Al-Khwarizmi, the placeholder zero. Then it travels over to North Africa, where it's picked up by Fibonacci, Leonardo Pisano, who took it from North Africa to Italy. From Italy, it then made its way to England. And so all the while that zero was travelling from India westward, all those people were not aware of India's original concept of zero. So Al-Khwarizmi, the traders in North Africa, Leonardo Pisano, Fibonacci, Robert Record, none of them got the correct information out of India. So Robert Record, I invented the sign equals, and I introduced the pre-existing sign plus to England. Yet I never knew about your zero definition, Mr. Brahma Gupta, or laws of positives and negatives. So, in the year 1478, the first book printed on maths, the Treviso Arithmetic, said numbers start at 2. So much for 0 and 1, which is all your computer needs. So this is basically 1,000 years after India worked out how mathematics works, and then 1,000 years later, they're saying numbers start at 2. This is insane. This really should be just front and centre of anyone talking about the cultural heritage of India. In 16th century England, people were using Roman numerals and there was no Roman numeral for 0. So when they were mapping the Roman numerals against the new Arabic or Hindu Arabic numerals, they often left the 0 out because there was no Roman numeral for it, and they would just kind of tack it on the end as a placeholder. So the maths at the time was based on ancient Greek maths, which did not have 0, 1, or negative numbers. So we get into some of the falsehoods of mathematics. The false idea that negative quantities are less than 0, rather than opposite in nature to positive quantities, emerged in Michael Stifel's Arithmetica Integra of 1544 in a section titled The Signs of Addition and Subtraction and of Absurd Numbers. India's numbers are absurd. They just could not understand what on earth might possibly be there. So Michael Stifel said negative numbers were below 0, which is below nothing, and therefore, because negative numbers were less than nothing, they were absurd. So to make sense of numbers that count or measure negative quantities, i.e. negative numbers, all we need to do is to drop the nonsense notion that negative quantities are less than 0. Then negative numbers simply count or measure opposite quantities or forces which are always greater than 0. Perhaps you might recall Newton's third law, which states for every action there's an equal and opposite reaction. Bingo. So Newton's laws of motion are consistent with Brahma Gupta's laws of quantitative mathematics, which are also consistent with quantum physics. If you think about it, 3 negative electrons and 3 positive positrons cancel each other out to sum to 0. If you are up to date with the latest theories of the universe, there's actually a theory that all of the energy in the universe sums to 0. It's often called the zero-sum universe. We've got laws of the conservation of mass, we've got laws of the conservation of energy, and all of these ideas are perfectly consistent with the Sanskrit-based mathematics that children will start to learn in class 1. So, this is where the evolution of maths went off the rails. As maths books got published in the English language, without 0 or 1 in the algorithmic definitions or as numbers, they were exported to England's settlements and colonies, such as New England, and New England becomes America. So the English had the printing press, they had this captive market of all their settlements and colonies around the world, so they began exporting their very badly structured explanations of Indian mathematics to the world, with broken definitions, totally false ideas that were absolutely absurd nonsense. And as an aside, if the English had been at war with the Irish instead of the Dutch in the 17th century, the directions on our number line could well have been reversed. We could have had negative numbers going off to the right and positive numbers going off to the left. That's how whimsical and arbitrary things like the number line concept actually are. Because in physics, if that's negative, that's positive. If that's negative, that's positive. Because all negatives are an additive inverse of whatever you deem to be the starting quantity or energy. So I've had the luxury of starting from the idea of quantum physics and going back in time, and also starting with ancient mathematics and going forwards through time and making sure that there's a complete consistency with the ideas of elementary mathematics. So as the English language spread, so too did major misunderstandings of India's mathematical foundations. In the year 628, Brahma Gupta gave solutions to equations we'd write today, such as x squared minus 92 y squared equals 1, and ax squared plus bx plus c equals 0. And that's the minimum answer to that equation, if you wanted to have some fun and work it out. However, so that's the sort of stuff Brahma Gupta was doing in 628. Almost 1,000 years later, the West is debating whether 1 is a number or not. So the first person that says 1 was a number in the West was Simon Stevan in 1585, almost 1,000 years after Brahma Gupta. So the West still does not understand Indian mathematics. They have not understood it yet. So where is 0 today? Well, this is my laptop, and that's where 0 is on my computer. It's in the wrong spot. Why is it there? Because it's an afterthought. All numbers start at 1. All of the charts of counting from 1 to 100 start at 1. What's the only number that is never said when children count all the way from 1 to 100? 0 is never even heard when children count from 1 to 100. So where should the 0 be? It should be in its correct position in front of the 1. But how stupid is that's just a legacy. We are very slow to bring about change, and we get stuck. We totally get stuck. Like the QWERTY keyboard was to stop the physical keys getting jammed. People have designed keyboards that are faster to use, but no, we just stay stuck with the relics of the past. That's what our elementary mathematics education is today, a broken relic from the past. So, just going to Brahma Gupta's laws, you can see them all there. I'm going to give you an example of how the laws of maths that you are teaching your children today are different to Brahma Gupta's laws. So, when positive and negative are equal, the sum is 0. This is correct according to the laws of physics, yet not what we are taught in school. Because in school, we're taught that every number to the left of 0 is less than every number to the right of 0. And the more left you go, the smaller the number. And even though I think 0, having nothing is not very much at all, you can actually have infinitely less than nothing. Now, my golden rule is, if anything in mathematics seems stupid, it is. It actually is stupid. And that was the thing that for decades, I've been wrestling with. We've got all these famous mathematicians and great eminent giants, but they're talking absolute nonsense. Sorry, I'll calm down now. No, it's not the more left you go, the smaller the number. I mean, imagine if we travelled 7 kilometres west. Is that less than travelling 4 kilometres east? No, it's more. We eventually start to talk about absolute value in our curriculum, but that should be the way that we start. We should start talking about numbers having an absolute value, and we have opposing units. And they're really fun games to play with because they cancel each other out and you remove them from the game board. Okay, so this is where some of the theory went wrong. The maths pedagogies in the West were developed on the naturals and then extended via subtraction to form the integers. So I want you to answer this. You're now all the children in class 2. So 5 minus 1 equals 4. Okay, you've got the swing of it. 5 minus 2 equals 3. 5 minus 3 equals 2. 5 minus 4 equals 1. I can tell you're professors. 5 minus 5 equals? I'm just going to leave that empty because, it's just an empty space. There's nothing there, an empty space. Now, this is the set of natural numbers. And what the West were talking about, they're saying, well, the set of naturals is great for addition and multiplication because they're closed under those two operations. You can add any two natural numbers, you can multiply any two natural numbers, and the answer will always be a natural number, but you can't do that with subtraction. You can't subtract any natural number from another and have it appear in the same set. So they extended the pattern. So it then became 5 minus 6 equals -1. 5 minus 7? -2. And therefore, by extending the set of natural numbers, that's how the set of integers was created. Now, I'm oversimplifying, but the actual logic behind what's going on is the important thing to understand. So what the West did is they looked at the pattern. The West wrongly extended the naturals pattern onto the integers. So we say, well, 4 is greater than 3, 3 is greater than 2, 2 is greater than 1, 1 is greater than 0, so 0 must be greater than -1, and -1 must be greater than -2. But no, really bad idea. Because that's not how physics works, and it's not how Indian mathematics works, and it's also not how ancient Chinese mathematics worked either. If you wanted to have a visual metaphor for how the number line really looks, you've got to do something like this. You have 0 in the middle, which means you've got no negatives and you've got no positives. And then the further away from 0 on either side, you see that the number, here we've got 1 positive and we've got 1 negative. The numbers are the same, but it's the unit which is oppositional in nature. And it doesn't matter which side we have positive or negative quantities, the same logic will apply. So 5 positives and 5 negatives sum together to 0. So it's almost like with the Big Bang, the universe started from nothing. It's almost like the same could be said for the real number line. From 0, unpack that 0, and then boom, symmetry comes on either side, and you have a whole lot of beautiful patterns that start to reappear. So I call that the B line in honor of Brahma Gupta. So we don't say that, for example, that 5 blacks are less than 2 red. That would be a nonsense idea, because if we combine 5 black and 2 red, the 2 red and the 2 black cancel each other out, and you're left with 3 black. So 5 black are greater than a smaller number of red. Very simple, very intuitive. And I teach this with cartoon storybooks to children. They have no problem understanding. So when the number of positive and negative quantities are equal, the sum is 0. I'm just trying to ram that home. So we can now look at the number line in a slightly better pedagogical way. And we can see that to the left of 0, all we have are counts or measures of negative units. And we've got examples there: electrons, south, west, left, down, debts, loss, deaths, immigration, cold, decay, below 0, less than enough, below ground, to the hour. So these are all things that can be measured or counted with the same set of numbers on the other side of 0. And if you took one of each of those ideas, together those opposite quantities are going to sum to 0. So I'm just going to mention proof by contradiction to prove that the West is wrong and India is right. If we look at Brahma Gupta's subtraction laws, subtraction law number 1 is a smaller positive subtracted from a larger positive is positive. So a smaller positive is positive 2, and it's less than positive 9, subtract it, and the answer is positive. And subtraction law number 3, if a larger positive is subtracted from a smaller positive, the sign of the answer changes. So positive 6 is greater than positive 4, so you can see that the sign of the answer has changed. So we're doing simple demonstrations of how Brahma Gupta explains mathematics very simply. So we can give that a thumbs up. But subtraction law number 2, a smaller negative subtracted from a larger negative is negative. So we've got 8 negatives minus 5 negatives equals 3 negatives. I've put the nouns back in, suddenly it becomes simple. But guess what? The smaller negative is negative 5. We don't teach that. We say negative 8 is less than negative 5. We'll often say, think of negatives as debts. But a debt of 8 million rupees is greater than a debt of 5 million rupees. So Brahma Gupta's own laws, your own laws, you're confusing your own children with because you're following the laws of the West. So, subtraction law number 3, if a larger negative is subtracted from a smaller negative, the sign of the answer changes. So again, negative 7 is larger than negative 3. 7 negatives are greater, obviously, than 3 negatives. So that is a huge shock. If you actually go back to the start of where mathematics began, you'll see that what you're teaching India's children is actually going against the laws of your own mathematics. So my time is up. I'm up to 58 minutes and 28 seconds. So thank you very much for your attention. I've really enjoyed my time in India. I'm not sure if we've got too much time for questions, but I'm very happy to chat with anyone at any time. Thank you very much again.
Thank you very much, sir. That was a really fascinating exposition of a possible new pedagogy for teaching negative numbers and zero. Thank you. I think let's hope we can take it forward. I think it's an extraordinary initiative that you are pursuing. I think from the organizers,
No watch. I will wear it.
Just open it up. Thank you very much.
Okay, thank you, sir. Actually, whole definition of zero and negative and positive numbers and about Brahma Gupta and all things, we are like, really mathematics have made us more confusing, and today we are all thinking again, and we have to go back and also have history. So you want to ask something? Yeah.
The whole theory you have demonstrated is fantastic. I just want to know that if a positive number and negative number you have to introduce probably the same time, that is how this theory will work. Positive number and negative number we have to introduce the same time.
Absolutely. Yes.
Probably this theory will work, otherwise it is not going to work. I just feel that.
I'll explain how you do it. You're now 8-year-old children. Okay, you're no longer professors, you're no longer mathematics teachers, you're now 8-year-old children. And I just get you to close your eyes and you listen to a story. And what we do is we go to the beach. And at the beach, it's a lovely, beautiful day, and the sand is so smooth and it's hard-packed, damp sand. And I give every child a square-sided bucket. And guess what, kids? We get to dig holes in that sand and we get to make some bricks. So what we then do is we start to dig some holes in the sand and we make some bricks. So we start off at ground level 0. There are 0 holes and there are 0 bricks. And probably within the second story, I say, well, imagine this time we've dug a hole that's 7 deep. Whoa, that's a long way down. But you don't have 7 bricks, you've only got 4 bricks. Now what would happen if we added the 4 bricks to the hole that's 7 deep? Will it fill it up? And the children go, no. And I say, what do you mean it won't fill it up? It might. And they go, no. And I say, with your eyes shut, what will happen if in that hole 7 deep, we drop the bricks which are 4 high, and they all tell me that the result is it's not enough bricks, and that I need 3 more bricks, or it's a hole of 3 deep. And you now have a metaphor for children with the first introduction of positive and negative that is using their imagination. And they absolutely know how integer logic works. Then from that point on, you do stories about ice blocks and hot rocks in a bathtub. And you use that same logic again and again with different ways you get the child to imagine playing in the game. How can we increase the water in the bathtub when it's got 10 ice blocks and 10 hot blocks in it? Well, we can increase the temperature by adding more hot blocks. Or what if we took out some of the cold blocks? Okay, children are very able to understand integer logic if we start to teach them the correct way from ancient India.
Thank you, sir. Thank you so much. We felt like we have gone back to our school days and again learn things in a new way. So I hope so your journey also continues in positive way, and also we get more insights. So thank you so much for coming here and sharing your views. I hope you will have more chance to interact with sir. Thank you.